It's that time of year again, winter. Love it or hate it, it sometimes brings us a little extra snow or a nasty cold snap. So every winter about this time, we hear another objection to the reality of climate change. And it goes a little like this. I looked outside and it was cold, therefore there is no climate change. Let's examine this little jewel of deductive reasoning.
The northern polar jet stream is driven partly by the temperature contrast between masses of icy air over the North Pole and warmer air near the equator. Climate change has led to faster warming in the Arctic than in the temperate zones. Research suggests that this reduction in the temperature difference is robbing the jet stream of some of its strength, making it wobblier and contributing to more temperature extremes. The jet stream is strongest in winter, when it has the greatest effect on weather in more densely populated parts of North America and Eurasia.
When I started my career in the Arctic in 1981, 85% of the Arctic basin was covered with multi-year sea ice, which is this stuff that survives the summer and grows the next year and is very thick and hard. Well, now only about 12% of it is multi-year sea ice.
The thick multi-year sea ice has now transitioned to thinner first-year ice. So it's gone from like 10 feet to 2 or 3 feet and is much more mobile.
The sea ice dynamics in themselves have impacts that go far beyond just the ocean, so to say, where the sea ice is.
There are signs of a connection between the Arctic and the rest of the world.
Those connections, teleconnections, as they are sometimes called, should be studied further.
There's what we would call an emerging signal, an association between the loss of sea ice and the warming of the Arctic and the frequency of severe weather events, especially during the winter season in mid-latitudes, in particular eastern North America and eastern Asia.
You have this big heating in the Arctic area.
And that causes the polar vortex, which is a byproduct of the high pressure pattern over top of the pole. It's causing that to break down because you've got a lot more heat coming from the ocean up into the atmosphere.
That essentially changes like the jet stream. It causes the jet stream to kind of do dips farther down.
The polar vortex is the jet stream.
Whenever you see big storms coming or heat waves, if you look at the jet stream, you'll see these big dips.
What happens basically with the polar vortex is you get a lot more lobed structure to it, and those lobes penetrate down far over top of the planet towards more temperate latitudes. If you're on the outside of one of those lobes, there's a tendency to draw up warm air much further into the Arctic than you would have otherwise. And if you're on one of the cold sides, you'll draw down cold air down into that lobe on the other side.
And so you get more extreme heat waves, more extreme storms, more extreme cold.
And so people in the southern states, for instance, will go, man, I'm in southern Florida and it's like freezing cold here in February.